technical questions about how our products work, I'm happy to respond as best as I'm able and sort of take those in and get back to you. I joined Google specifically because I wanted to work on this Renew product that I'm going to talk about, but also more generally because I think the company can be doing a lot in the world of kind of clean energy, energy efficiency, and climate, and I wanted to help it sort of bring the best of what it's able to do well to this field. I'm not a salesperson. As Rebecca said, I'm a product planner at Google, which means I think about strategy, business stuff. So not a salesperson. I do want to talk about some products today. I will try not to overpitch those things, but I think they're illustrative of the things that the company thinks about, what it's working on, sort of general philosophy, and might be of just general interest to this community. However, I'll just say that the company does a lot of stuff, big company, and I definitely don't know it all. So again, if you have questions about things that the company is up to, data center questions, other product developments that you've heard about, happy to be as responsive as I can be, happy to take those questions in and get back to you. Just a couple of points, I think on the next slide here. Yeah, just a couple of observations about sort of philosophy. This is kind of my perspective on what I have seen since joining the company. But we're basically all about helping customers. So everything that we do at the end of the day sort of takes the lens of how does this help someone on the other side of the computer? And a lot of that help looks like information, right? So the search products that everyone knows. And a lot of that is sort of intelligence that we think, the intelligence that's easy to use, making that kind of intelligence more accessible to customers. And I think our smart thermostats are a really good example of that. So that kind of information and intelligence combination can be offered at the level of the community. And that's one of the products that I'm going to talk about today. It's actually a product that I don't work on, but I just think is cool. And it's kind of relevant to stuff that I have done in my previous life. And the other kind of intelligence and information sharing can be done at the level of the household or the consumer. And that's the product that I do work on, this Nest Renew product that we recently announced and launched. And so I'll talk a little bit about that too. And then just for this group, maybe one other obvious point. I don't even know if this would be particularly controversial at this point, but I'll just say it anyway because it matters to how we think about things, which is that we're seeing a real blurring of, maybe even collapsing of the categories of energy efficiency and demand response. And given that collapse, we actually think that that's works better for the world in terms of how we interact with this world. And so I'd be interested in getting folks' feedback on that as well. Anyway, so those are kind of just general observations about philosophy and what I've seen from the crew so far since joining Google. Okay, so let me do a quick walkthrough here, and I will try and be quick on this stuff. So next slide. Okay, so at the level of the community, I wanted to talk a little about sort of like community intelligence that we're able to offer and why I think that this product is relevant for this sort of smart community discussion and for helping communities think about managing a developing portfolio of energy efficiency, demand response, and clean energy opportunities. So it's this thing we call the Environmental Insights Explorer. And as you saw, it's about sort of helping the planet. That's fine, keep moving. Stuff probably this group all knows. We need to do a lot of work real fast at scale to tackle this climate change problem. Next slide. There's Sundar, our CEO. We won't play the video. I'm not even sure you could play the video at this point. But one of the things the company has made a real strong commitment on over the past, for years it's been doing this, but it's really focusing on now, as I said, sort of bringing the best of what Google is able to do to help the world tackle its climate change problem. And specifically, this thing is about working with cities and local communities, where I think probably everyone in this call would agree, a lot of that heavy lifting, frankly, has to happen. Next slide. So the point I just made, but what does it actually look like to be helping a city? One of the things that we've observed and where we think we can be helpful is helping cities actually understand, helping communities actually understand kind of what's going on the ground, what the opportunities are, how they are making progress against those opportunities. And so we feel like there's sort of been a lack of data and insights, which have made it challenging to create actionable plans and then to actually sort of observe and mark progress against those plans. So we've created this thing, the EIE, and it's essentially a community dashboard. We have attempted to strike relationships with a bunch of different communities around the country, around the world, and are interested in having more of those kinds of relationships so that we can help folks make use of this dashboard to, again, sort of chart a clear course forward. So it's available to folks all over the world, whether we have sort of a direct relationship with you or an indirect relationship with you. We're offering 9,000 current city data sets. We're interested in building out the product to provide more of that. And again, it's about, I think if we go to the next slide, we start to sort of show some of the, it's about, again, sort of helping chart a course forward. And I think for purposes of this discussion, a big piece of that, I think we start talking about the sort of the building side of it in the next slide. Right, so building emissions, a big piece of what we are attempting to capture here. Again, it's about a comprehensive plan. And for purposes of this conversation, I think because we work at the level of individual households and at the level of communities, a product like this can be helpful for as communities are trying to get smart, build plans to go forward and are thinking specifically about the energy efficiency opportunities available in their building stock. This is a great tool for helping to kind of create that holistic, overarching view of things and to track progress. So some of the folks working with us, again, happy to talk more about this and put you all in touch if this is interesting to people to hear more about the product. But again, think of it as a kind of a dashboard for local communities for sort of keeping track of overall progress. I think that might be the last one on this EIE product. Let's go to the renew thing. I'll just keep moving through more sales materials here for everyone. Okay, so then this is the thing that I work on, and this again happens at the level of an individual household. And our goal with launching the renew effort here was basically to take what we already do well, right? These Nest thermostats and someday maybe other technology in the home, and help folks start supporting a clean energy future today. So go to the next slide. And so the product will basically be, as we'll see in a second here, it's an enhancement to the capabilities that the thermostat already brings to customers today. That's the free piece of the product. And then there's a premium piece of the product, which is about helping customers bring more clean energy to the grid and to enhance their impact on climate and clean energy through a variety of other not-for-profit mechanisms, sort of a curated not-for-profit portfolio that we bring to the table. We can keep going here. So a bit of a sort of celebration of ourselves for what we've already done with the thermostat, and recognizing that that's a big part of the energy efficiency and demand response opportunity, but also recognizing that folks want to do more. And so there were sort of two questions that we posed to ourselves and we are trying to answer through the development of this product is, what can we do today that has immediate impact through the technology that we have, the reach that we have, and then what can we do in the future to help really support rapid build out of clean energy resources on the grid and optimization of those, optimization of the demand side to meet those clean energy resource availability timeframes. So there's a set of screens that kind of give you a sense of what the product is. It's more to make it sort of tangible and tactile for folks. And again, happy to talk about sort of the macro thinking here in a second. But just very quickly for what it does is it allows you to kind of see the current grid mix, see what you're using at the moment. You can kind of fly through this, Casey. But part of the new capability that we offer folks is this thing that we're calling Energy Shift, which is about taking our existing demand response capabilities and marrying it to the ability to slightly adjust your usage for cleaner times of the grid and away from dirtier times of the grid. We can help you if you want our time of use plan to make sure you're optimizing your usage for that time of use plan. We're heavily interested in, and I think there's a slide in here that sort of highlights some of our partnerships. We're very interested in making use of this opportunity to talk to customers through the Renew platform to make sure that they're aware of various utility programs that they can avail themselves of. And this can, in today's world, this can be about supporting, acquisition of a smart thermostat or other electrification opportunities. And one could imagine where this platform provides a whole lot of interesting ways for utilities and communities to interact with customers and users. Let's keep going. We have this impact piece of things, which is a sort of a gamification thing we do, where the more work you do through Nest Renew to improve the grid, the more leafs you earn, and you can effectively deploy those leafs to increase your impact through this portfolio of not-for-profits that we are partnering with. And then we have this early days on this, but we have this premium product that we're starting to roll out, which allows you to begin to invest in bringing more clean energy resources onto the grid. I call that Clean Energy Match. We'll just keep going here so I can reserve. We're going to focus that energy procurement on the dirtiest parts of the grid. And so here's a slide that just sort of gives you a sense of kind of our two tiers. Again, the basic tier is essentially a deep enhancement of what the thermostat is able to do today. And the premium tier is about supporting the acquisition of additional clean energy, particularly in the dirtiest parts of the grid in the United States. And then a little slide on some of the folks we're working with, including Southern Company. Excited to hear the presentation today. But these are some of the utility partners who've already announced that they'll be working with us. And we are very excited about this because we think sort of taking what these folks are already doing and helping to make it stronger, better, more accessible for their customers is a big part of the value proposition to the system and to our partners. So that's it for me. We're gonna take Q&A at the end. Is that the plan?
I believe so. Yes. Does that work for you, Kevin?
That's totally fine. Yeah. So I'll just pause there and just conclude by saying thanks very much, and also very happy to talk about any of those specific products, or again about sort of philosophically how Google might be helpful enhancing the effort that we're going to hear about from everyone else.
Just a quick reminder to everyone as well. Please post questions as we go along in the chat. They'll come straight to me, and I will share them with Casey and the rest of the group at the end.
Great. Thanks, Rebecca. Kevin, thanks so much. Looking forward to really getting some little bit more questions at the end. So I appreciate your flexibility there. Okay, our next speaker is Phil Markham, and he is the Smart Buildings and Research Development Supervisor at Southern Companies. Phil and his team test and pilot the end-use technologies that can provide efficient decarbonization via electrification or low carbon fuels, increased customer satisfaction, and overall electric power system benefits. He joined Southern Companies in 2011 after working in the electric power industry in Australia. Since joining Southern, Phil held roles in increasing responsibility in the transmission planning, system planning, and solar power plant asset management before joining the research and development in 2018. Phil has an exciting presentation that some of you might already know a little bit about. So Phil, go ahead and take it away.
Thanks, Casey. Yeah, just on my background, a little bit like Kevin, I'm not steeped in demand response and energy efficiency programs. I've become familiar with them over the last 3 or 4 years, but I'm an electrical engineer by trade. Have managed large-scale solar plants, used to be in transmission planning, generation development. So I'm very much a power system grid kind of guy. Care about renewable energy, care about keeping the lights on at an affordable price. Yeah, next slide, please. So yeah, I've had the pleasure over the last few years of managing a team of engineers working on a whole bunch of projects, but two of our biggest projects being the Smart Neighborhood projects in Birmingham and Atlanta. Southern Company has Southern Company is the holding company for 3 electric utilities, 2 of which are Alabama Power and Georgia Power. The first one was that we got off the ground. We actually wanted to do them at the same time, and then just permitting and planning. Anyone who's been involved in development knows that sometimes things can get slowed down. With the Georgia Power Smart Neighborhood, kind of got slowed down. Now it's midway into the research phase with its 46 townhomes, and everyone's moved in, and we're doing research there now. The Alabama Power Smart Neighborhood, our 2-year research phase, is actually over. And so the 2 communities are slightly different. And you know, what are these, and why did we even do them? So back in, but even before I was in research and development at Southern Company, some researchers at Southern, together with some other industry folks that work at the DOE National Labs, some really forward-thinking people, started brainstorming. Okay, what is the community of the future going to look like? You know, so this was back in 2015. And you know, what does the power grid need to do to serve it? So that was sort of the question. And so these communities, the Alabama Power community is 62 single-family homes. The Georgia Power community, the Smart Neighborhood, is 46 townhomes. Each of them combine distributed energy resources, energy efficiency, and smart devices, and sort of buildings to grid or device level load control interaction with the electric power grid. So they all kind of combine that. The Alabama Power Smart Neighborhood actually has a microgrid about a mile away with I think it's about 330 kilowatts of solar, a battery, and a gas generator. And then that actually serves the neighborhood. So if the grid does go down upstream, the microgrid can pick up that neighborhood there on the right. I don't know if you guys can see my mouse if I move around. But yeah, it can actually serve that neighborhood. The townhomes in Atlanta actually have batteries in the garage, and some of the home is fed off a critical load panel. So the top level of the townhome, the lighting, the kitchen area, the security system, the internet, you know, certain loads are fed off a critical load panel. So if the power goes out, batteries in the garage can sustain those townhomes. And you can see, you know, there's so much to talk about here. You can see we had a lot of help, a lot of vendor partnerships and research partners as well as we did this project. Next slide, please. Just a little bit more about the objectives. I think I already spoke about this, but you can see, you know, again, the 3 elements we really tried to combine were distributed energy resources. So think solar, batteries. In the case of the Alabama Power neighborhood, we also had a community scale generator, energy efficiency, and smart device load flexibility, controlling loads in homes, controlling customer devices based on grid needs, but maintaining customer comfort. So those are sort of the 3 elements. Next slide, please. It's a pretty overview shot via a drone of the neighborhood in Alabama. Next slide, please. And that's that microgrid I told you about that is a mile away. So it has the solar, the battery, a generator, and a load bank for electrical engineering reasons, which we don't have time for. Next slide, please. So the homes, in terms of energy efficiency, so we should talk about that, right? Given the name of today, those of you who are familiar with the home energy rating system, or is it SCORE, HERS, you know what I'm talking about. These homes have a HERS rating of about 42. So the lower the score, the better. Like in golf, that's a really energy efficient home. So we baselined this neighborhood against an all electric neighborhood down the road. And this neighborhood was over about a 2-year period was about 40% more efficient on a per home basis. And you can see some of the features we've got in these homes. You know, triple pane windows, a heat pump water heater, extremely efficient, variable speed heat pump for the heating and cooling, space heating and cooling. Actually, I wanted to ask Kevin later, and it may have been announced and I may have missed it, but if Nest has any plans to work with some of these really advanced heat pumps that are variable speed. So, you know, most folks right now, their heat pumps a single stage or two stage. There's inverter driven heat pumps now on the market that are super efficient. And my understanding is, this is maybe something we can talk about later, but my understanding is the smart thermostats don't typically interact with those heat pumps, or if they do, it's in a limited way, because it's tough to get inside the control loop of those heat pumps. So anyway, we can talk about that later. 2x6 construction, you know, most homes are 2x4. These were built with 2x6 so you can fit more insulation in. So lots of features to make them super energy efficient. Next slide, please. So each of the homes in the Alabama Power Smart neighborhood had a tablet on the fridge. It wasn't a third-party tablet attached to the fridge. It was actually part of the fridge. And we actually were able to show the per circuit energy usage for each of these circuits. So homeowners could, you know, they'd have their calendar on the fridge. They could also come and see, okay, what is, you know, where's my energy being used? What's the, you know, rough cost? We didn't have the color my electricity thing like Google and Kevin was just showing it. So I think that's a really interesting idea. But you know, you can see that was sort of the interface to these homes for people, and we got really good feedback from occupants, the homeowners. They like to be able to see where their energy usage was and how the cost broke down. All right, next slide, please. So, you know, I mentioned that I won't go into this in too much detail, but, you know, mentioned that distributed energy resources were part of it, this research project, mentioned that efficiency was, and then I mentioned that a control infrastructure controlling certain customer loads as part of the research project. To me, that was one of the most interesting parts of this project. So in these homes, we controlled the heat pump water heaters and the space heating and cooling heat pumps. We wanted to control EV chargers, but of course, it's you know, this you can't guarantee that the homeowners would have an electric vehicle, right? And there was 2 of the homeowners in the research period did have electric vehicles, but we couldn't, you know, control 62 electric vehicle chargers because not everyone had an EV. So we controlled water heaters and heat pumps. So how do we control them? What did we do? Well, we sent the devices a time of use signal. So basically, you know, is electricity expensive? Is it cheap? We controlled it on that basis. We also did things like maximizing the solar consumption. So, for example, let's say you were looking at the weather forecast, the controller could see that you're going to have storms coming through in the afternoon. And you were monitoring what the ambient temperature was going to do. We could actually, and let's say it was August in Alabama, right? So it's hot. You could pre-cool the homes a little bit, so run the air conditioning a little bit more when the solar output in the morning was high, and then you could turn the air conditioning off and kind of ride through the afternoon a little bit when the solar production was down. So you don't just have to control those loads by price, you can control them by the color of the energy, as Kevin would say. So that was really interesting. How did it go? So what we found was basically controlling water heaters is pretty easy. As long as you don't give anyone a cold shower, they're fine. You don't get any complaints, and thankfully we never did that. Now I will say, well, let me come back to that. thermostat, controlling the thermostat is, I think, a lot trickier. We had opt-outs. People could opt out, obviously, of the control, and we can talk more about that later. I think that's a customer segmentation thing. I think there's some tricks around how you do that. But just the 10,000 foot view and the question I have about energy efficiency and demand response, and Kevin kind of primed the pump on that one, is some of these appliances now are so efficient that I think the question we need to be asking is how much is, I think we should at least be asking the question, is it, what is the bang for the buck? What is the impact in controlling some of these really efficient devices? So is it worth having all the control infrastructure, the communications infrastructure, the data storage, right? You've got to store that information so you can process it. Is all of that worth it for the resource? So maybe we can come back to that. Next slide, please. So how do they perform? Here's some real data. So I said that we had a baseline neighborhood down the road in our Birmingham, Alabama neighborhood. This was on a cold day for Alabama. Not cold, I know, for some of you around the country, especially in Virginia. So you can see here that home one put out of that baseline neighborhood was it up at about 13, 14 kilowatts. It was using the heat strip, which is why it was so high there. And then you can see over here on the right, a smart neighborhood home, most of the times below 5 kilowatts. This is whole home usage, by the way. It's not actually pulling just the circuit using the air conditioning or the heating in this example. So the home on the right is below 5 kilowatts. The spike there is reverse cycling the heat pump just to make sure the coils don't freeze, so it spikes up. But as you aggregate all the homes, thankfully each home doesn't spike at the same time. Next slide, please. So you can see that the overall usage for the neighborhood was about 60 to 80 kilowatts, which is very good for that kind of temperature. And when we baselined it against the neighborhood, the baseline neighborhood, it's about a 40% reduction on the peak, which is a pretty big deal versus that all electric baseline neighborhood, which was built in 2015. Next slide, please. I'm not going to talk about this one too much. Maybe Casey, just if you could jump through these slides, just because of time here. So maybe, yeah. So I think probably instead of going through this one, solar on the roof and these ones, I think probably I'll just finish with some lessons learned to date, and we can kind of come back to some of this in question time. So lessons learned, what did we learn? So in terms of the customer interface for these smart homes in this community, one of the things I asked when I came on board was, well, hey, do we have one app to control them all? So there was a bunch of smart devices in the homes. Do we have, one sort of Alabama Power branded app to, where the customer can use that to control, the air conditioner, the heat pump, the whatever, the smart lighting. And we didn't do that. And my takeaway was actually that, all of us who have smartphones, how many apps do we have on our phones? Like so many, right? Maybe 100. And my takeaway was that actually just the ease of use of the interface is more important than anything else. You don't necessarily need one app to control a energy efficient smart home. You just need the apps that you have that do allow people to change the lighting and turn circuits off and on. You just need it to be user friendly and easy to use. We learned that no community is smart in the customer's eyes. No device is smart. No community is smart if you can't keep the lights on. So if the power is not reliable and resilient, I mean, resiliency is king, queen, and everything else. And so, yeah, we can talk more about that later. But as an electrical engineer, power grid background, that's still really front of mind for me. I mentioned about in terms of if we're moving into this future of where energy efficiency and DR kind of blends, like Kevin mentioned. I think that at the residential level, I think we'll have a spectrum of customers. You know, Kevin knows about customer segmentation better than I do. I think we'll have some customers who are willing to do that, some who aren't. I think it's going to be interesting to see how that plays out. I think we have to, you know, we saw the cost to store the data and manage the data that was used to optimize the loads according to price or renewable energy. When you're thinking about loads as a resource, you have to think about that cost as well. That's just something to think about. So the communications, where you're going to store the data, the sensors, all of that stuff has to be incorporated. Just one, this may be a little bit too technical, but as these communities scale, if we are communicating to, you know, all the thermostats and all the water heaters and all the electric vehicle chargers, the communication and control infrastructure, we're gonna have to think about that very carefully. People far smarter than me are thinking about that. One of the takeaways I've heard is that control infrastructure, communication infrastructure has to be decentralized to maintain speed, I mean, usability, reliability, and resiliency as well. And my final takeaway is energy efficiency and an energy efficient appliance is a really robust, the way Kevin talked about and blending. I've started to think about a really energy efficient appliance just standing on its own as a persistent demand response resource. So as we, are trying to electrify certain parts of the industry, transportation, at the same time as we're trying to make the grid greener, I think we need to really think about appliances, air conditioners, water heaters that are really efficient and actually don't need any input. They just kind of do their thing. If it has a communication breakdown, there is no local controller or global controller that needs to control that thing. It just is really efficient. It does its thing, and it helps us electrify more things in that way. So I think I'll stop there, KC. Thanks so much for listening, everyone. I look forward to the discussion at the end.
Wonderful, Phil. And thank you all for going ahead and submitting your questions to Rebecca. She's been feeding me some of these, and it sounds like we have some good questions here. Okay, I'd like to introduce our third panelist here. Dr. Damian Pitt is an associate professor of urban and regional studies and planning in the School of Government and Public Affairs at Virginia Commonwealth University. His research focuses on the role of state and local governments in facilitating a transition to clean and renewable energy sources. He has written numerous academic articles and professional reports, including studies for the Virginia Department of Energy, the City of Richmond's Office of Sustainability, and CHESA. His most recent publications have addressed the value of distributed solar energy to the electric grid and opportunities to maximize the value through local planning and state energy policy. Damian, the floor is yours.
Okay, thank you, Casey. Yeah, so I see my role in this panel as to be discussing the sort of the perspective of localities and in particular the urban planning field on the incorporation of these technologies. The previous speakers spoke with some enthusiasm about what these technologies can provide for localities and for communities, but so I wanted to explore what is the role of urban planning and to help leverage these technologies and expand their usage. And I see some promise in, next slide, the I see this as a confluence of a few different themes within the urban planning field, particularly climate action planning and the smart cities movement, as well as obviously, as the previous speakers discussed, a connection to smart grid, distributed energy resource concepts. And so the two questions that I want to explore with this presentation are, what is the local role in supporting energy efficiency in general, and how can that be sort of expanded into looking at smart efficiency technologies? And then what are some examples of leading cities that have already begun to look at these issues and incorporate them into their planning or climate action agendas? So climate action planning refers to the movement over the last decade or so to address climate change through local municipal action, specifically primarily around climate change mitigation, reducing local carbon footprints, originally as a response to the lack of US action at the federal level to incorporate the goals of the Kyoto Protocol. And so this movement within urban planning does two things. First, it reframes some of the existing longstanding functions around land use planning and transportation to think of them as through the lens of greenhouse gas reduction and climate change mitigation. And second is looking at new opportunities for new functions and services and policies that localities can take on to try to support energy efficiency and renewables. We can skip this. I'll come back to that. And so the second stream of thought that this topic of today links into is the smart cities movement, which is looking at ways to integrate information and communication technology with urban infrastructure and public services at the local level. Next. And so the smart cities movement is primarily framed around using technology as ways to improve citizen engagement and or to better provide public service through quote unquote intelligent governance, sometimes linked to the idea of energy and resource efficiency. And so examples of that could be opportunities for smart and connected infrastructure, for example, streetlights, the Internet of Things concept, tying public infrastructure things that are part of the IoT. And the second being, second major connection to energy being the use of big data to optimize transit and transportation services. So in terms of the linkage of this to energy efficiency, given that smart cities is primarily focused on public services, I've seen, to a certain extent, I've seen the smart cities literature talk about examples of projects to share energy data among large institutional office buildings. So kind of like taking the concept of energy disclosure and benchmarking programs and putting sort of a high-tech spin on that. Next. And so the question is, to what extent can this be expanded into to what extent can cities help to expand these smart energy efficiency technologies into the urban fabric, into private buildings, beyond these large institutional office buildings, and beyond some of the examples that we were just provided of kind of like new greenfield sort of planned community type projects, so getting them into existing homes and businesses. Next. Moving on now to talk about some of the ways in which local roles and responsibilities and the urban planning field links into energy efficiency in general. For one thing, the primary thing that we're talking about at this point, talking about long range planning and looking at the things that cities do broadly to set forth their policy goals and recommendations through comprehensive planning, which looks at a variety of issues, including often environment sustainability, and sets forth broad recommendations for local public policy, as well as recommendations and concepts for working with the private sector and working on different types of public-private initiatives to pursue community goals. And then, so another aspect of this kind of municipal long-range planning function is looking specifically at sustainability or quote unquote climate action plans, which again look to reduce greenhouse gas emissions, as well as in some cases look at climate change adaptation opportunities. So this is a vehicle through which the idea of incorporating smart energy efficiency technologies would really make sense. There's an obvious connection there. One thing I will note though is that I think a lot of the progressive and sustainable cities these days are really reframing their approach to climate action and trying to refocus it on equity lens and looking at what is it that localities can do to address some of our inequities, energy burdens, and things of that nature, and via climate action planning. And in that regards, with that type of equity-based focus, I'm not sure to what extent the idea of like high-tech smart technologies and smart homes and so forth would really rise to the forefront. Next slide. So just wanted to review a few of the kind of more specific on the ground ways in which localities can support energy efficiency. One is, the most obvious one is through their building code authority, to the extent feasible, where, given that in a lot of states, localities are not, including Virginia, localities are not allowed to have local building codes that exceed the uniform state building code. The second element in theory would be the zoning authority, which primarily focuses on the types of uses allowed in a given building or on a given property. It regulates building size and height and so forth, and exterior characteristics, but typically does not get into interior functionality of a building other than is it residential, is it commercial, how's it being used. So the idea of requiring via zoning the use of these technologies is kind of far-fetched at this point. It's sort of outside the scope of what zoning does. So we have to look at other opportunities, and one of which is the incentive structure. And so this is a way to not require a certain type of outcome in our building development, but to encourage it. And so there are a number of different mechanisms in place to incentivize affordable housing or green building or what have you, and that includes fast track permitting processes, density bonuses, allowing developers to build more units or more square footage than are otherwise to be allowed under the base zoning. And so those tools can and are used to incentivize green building, and that can obviously include the incorporation of some of these smart technologies. And then the final item there is technical assistance, where again, this is one of the kind of new initiatives that cities are taking on as part of climate planning, is to serve as a sort of informational hub and source of assistance to homeowners, developers, to provide them with information around energy efficiency or renewables, connect them to resources for in the efficiency realm, energy audits, upgrades, et cetera. So, those last two categories are ones in which I think there's some promising connections to cities supporting smart technology. Next, yeah. Okay, so I want to look at, to what extent are cities actually incorporating this technology now? So I've done kind of just a preliminary review, looking through the lens of smart cities as well as climate action. Go on. So, there aren't a ton of US cities that have a quote unquote smart city plan or something of that nature. For the ones that do, it's oftentimes framed primarily around transportation. There was a federal grant program that the city of Columbus, Ohio, and other cities received grants to do a smart city plan that was really, transportation focused. Sorry. Others focus on, again, on some of that core infrastructure, fiber optic, streetlights, public safety, and cameras, which raises some concerns around privacy and so forth. So not seeing a ton of connection of smart cities to sustainability so far in the US. But, yeah. In terms of the climate action planning, I've done kind of a preliminary scan of climate action plans in some of the cities that I've previously, through other research, identified as kind of like leading cities on being most proactive and innovative, and when it comes to coming up with ways to reduce their carbon footprints of their communities. So I did a review of those plans, looking for to see to what extent are they discussing smart efficiency technologies. And I'm not going to get into all the details of the bullets here, but in some cases there was very little discussion of these opportunities, and in others it was primarily focused around the idea of benchmarking energy, building energy performance, data collection, and then a couple of plans, Portland in particular, talked of, well, with Austin, localities where, like Austin, that own their own electric utility will often sort of talk about opportunities for distributed energy resources, grid type stuff, like what the previous speakers discussed, and building that into their citywide climate action plan. So there's an obvious connection there. And Portland also talked about some of the sort of technical assistance and partnerships around smart technologies. But yeah, okay. So another thing that I've preliminary started to do that's part of further research I'm going to engage in is looking at to what extent do municipal comprehensive plans address distributed energy resources, and to what extent are cities being prepared for or looking for opportunities to support these new types of energy technologies, including in this case energy efficiency, some smart technologies. So what I've highlighted here is some examples from the new City of Richmond, quote unquote, Richmond 300 master plan, which was an award-winning comprehensive plan that was just completed a year ago and got a lot of positive attention. And I was a part of this process. I was the co-chair of the environmental committee. So we developed a series of objectives and recommendations around environmental opportunities, including energy and climate change. And we really framed all of the clean energy related recommendations around this idea of reducing air pollution. So give it sort of a broad sheen to it. So I've just highlighted a few things, examples here where the City of Richmond is looking to address energy efficiency through some of the mechanisms that I identified earlier. So in section A2 that I showed there, that's looking at some of these incentive structures that I'd mentioned before, and using those to encourage energy efficiency, which again, nothing in here is specific to advanced energy technologies, but we're looking at how is it that cities are, in this case Richmond, looking to encourage energy efficiency generally. And so there's a few things there I won't get into in more detail. Next, yeah. Another sort of element, another urban planning movement that I think has some connection here is that of eco-districts, which is a term that kind of applies to any sort of like neighborhood scale green planning initiative. And preliminary, I've seen a couple examples like as the ones you see linked there that have incorporated some smart building efficiency concepts. And this is, I think, largely around incorporating eco-district concepts into existing neighborhoods, as opposed to what previous speaker discussed. And then another piece of this is something called the 2030 Districts Network, which I wasn't really familiar with prior to prepping for this talk today, but it's an interesting concept that captures a lot of what we're talking about today in terms of looking at the high advanced technologies and how to support energy efficiency through, in this case, at the district scale in cities. And a couple of examples, this 2030 Districts Network can kind of approach advanced technology in a lot of different realms, some of which, including the city of San Diego, really focused on the energy and climate change opportunities that come through advanced technology in the built environment. one example that I found that I think is particularly an example of the potential for cities to support these technologies comes from the city of Boulder, and it's what they're doing is a lot of technical assistance through their quote unquote energy smart services program that is broadly around energy efficiency. So this is a technical assistance program for supporting energy efficiency, but it's one that's quite innovative in a number of ways, including the extent to which it's looking at energy optimization, demand management services, which naturally is going to include some of these advanced efficiency technologies we're talking about here. It is aligned with the city's building code initiative, currently called Build Smart, but for a long time, Boulder and City of Boulder and Boulder County have been on the vanguard of incorporating energy efficiency into the building code in a mandated type of way. That again is not something that many cities are even empowered to do, but the ones that can are typically not going to that degree of really mandating energy efficiency beyond to the degree that Boulder has for some time now. And again, the new version of that is this Build Smart program that requires a high efficiency building code, and it is sort of linked into these other initiatives around providing information assistance for energy efficiency, including advanced technologies, all of which is funded in part by federal grant, but also by their Boulder's unique in the nation local carbon tax program, essentially, that provides funding for this and many other climate action initiatives there in that community. So yeah, I think I'm pretty much done here. I think I have one more slide that just sort of talks about how this is part of some broader research that I want to do that looks at what cities are doing now around supporting the transition to distributed energy resources, including now, as a result of having been involved in this session, I want to look at the energy efficiency aspect of this as well. And so appreciate the opportunity to be involved in this today.
Wonderful. Thank you so much, Damian. You really did some heavy lifting and research here.
Yeah, it needed to be done. So I appreciate the kick in the pants to start looking at this aspect of the area, my interest area.
Well, I think I have a few questions that have already been drafted, and I did prepare some too, and was trying to take some notes as our kind of well-rounded panel here was talking. One of the immediate things, the questions that came up, and Phil, I'm going to steer this towards you but I think it really relates to how we can continue to drive this. But for the microgrid project in Georgia, could you let everyone know how that project was funded and perhaps tease out some of the opportunities for return of that investment?
Yeah. Okay. So both of those neighborhoods. So let's see. The Alabama Power neighborhood, which is the smart neighborhood, which is a single family home, 62 family home neighborhood with the microgrid a mile away. The microgrid is a Alabama Power asset. So that was a research project, but it produces energy for Alabama Power customers in general. So that was I believe a rate-based asset. The homes themselves were, obviously there was a developer and a builder. Homeowners paid for the homes. The incremental improvements were part of the research project were funded by Southern Company shareholders. So that's how that worked. And then in terms of return on investment, well, it was a research project, so that wasn't at top of mind. So I can say, the heat pump, that super efficient low temperature heat pump within the inverter driven variable speed that doesn't really use resistant heat was pretty expensive. The best payback was the water heater. So I can say the heat pump water heater that we used, I think paid back in like 18 months. That was 12 to 18 months. I think that was definitely the best bang for the buck in terms of creating elements to become part of a business case. Alabama Power actually did create a smart neighborhood brand that they've partnered with builders on. It doesn't go to the level of that neighborhood, but it does have some of the elements that make sense, like additional insulation and the heat pump water heater. It wasn't, I don't think they used the inverter driven, SEER 20, I think that HVAC system was. I think they used something more than code though. So it was, payback wasn't the goal, but we did look at some of the elements. But yeah, heat pump water heater, great investment.
And utility, right? Utility investment also for greater grid resilience and understanding of those interconnections between buildings. Yeah.
Right.
Okay, I would like also, Kevin, maybe you could share with us a little bit about a little bit more about the Environmental Insights Explorer and how a community might specifically engage with that, and what would that process be, and who might be the key players to be involved?
Sure. You would, of course, be asking me the question about the product that I don't work on. And so the answer is going to be, there's a slide in there that has a bunch of names, and those are the folks that one should reach out to. And if you want to circulate or get in touch with me directly, I am happy to put anyone on this discussion in touch with the folks that you would want to talk to at Google. The way that I understand that the team has sort of gone to market, if you will, on this product is that they have reached out to a bunch of the kind of bigger cities, have devoted a bunch of resources to building their own kind of proprietary dashboards. And so we have gone to some of the next not tier down, but the smaller cities, mid-sized cities, and reached out to them and sort of offered this directly to them. And we've sort of imported public data into the database, and as well as brought to bear some of our own tools, and then kind of laid that out for folks. So that's a kind of a discussion directly with the folks in those cities, working for the administrations in those cities about what they need and how to best to serve them. And so we have a team that actively engages with them. So again, happy to put you in touch with them. But the process is intended to be like super collaborative, and so we are very excited about talking to as many people as possible and then offering the product as much as possible. So sort of a vague answer to your question. The answer is talk to the people who are really expert, and talk to me if you want to find those people, because I can make it happen.
Great, thank you. And it sounds like, Damian, that might be interesting for your continued knowledge as well and research. Phil, Damian was hoping to know if the smart neighborhood programs included any kind of centralized energy storage within the neighborhood. I think you covered that, but perhaps you could. Okay.
Yeah. So the research projects did in the Alabama Power neighborhood. The microgrid had a 340 kilowatt, 680 kilowatt hour, so like a 2-hour, 340 kilowatt battery for the neighborhood. We learned some lessons there from an electrical engineering standpoint. It turns out that we hear about these microgrids and that's the future, and I think that there will be a lot of that. We had some problems with just the electrical configuration, and it was installed by the foremost microgrid company in North America. I think they've got over 90% market share. And just as an aside, just as for everyone, I remember asking a guy who's a PE, master in electrical engineering, like why did we have problems with this microgrid? I thought microgrid's been around for 50 years, powering remote mining operations and remote whatever. And it turns out that if you have a microgrid that is always islanded, it's not connected to the grid 100% of the time, it's remote, it does its thing. We know about that, we know how to do that. Microgrids that are normally connected to the grid but then have to be out of island are a little bit more new. They're new and a little bit more complex. So we'll work it out. But that was a learning. But yes, that was a long way of answering. Yeah, we had a battery which was able to sustain the neighborhood for, depending on the time of year, because most of the load's still weather driven, heating and space heating and cooling, for 15 hours to 2 days.
Yeah, I appreciate that. I asked because, I'm curious about, as I look into what is the role of localities in supporting a clean energy transition, and as energy storage is clearly a huge part of that, is our energy storage going to be primarily, I mean, obviously there's going to be, building integrated, residential, commercial battery storage, and there's already, transmission grid level storage facilities, but to what extent are we going to need something in between? They're like freestanding, separate, storage facilities that would become a unique type of land use that cities are in no way prepared to like zone for or regulate or figure out where they go and where they don't. And so it's potentially a pretty major, challenge in urban planning that on the horizon.
Question. Yeah, I mean, just to follow up thought on that, just related, batteries don't need as much footprint as solar, but it's interesting thinking about community solar. So you've got I used to manage the huge, large scale solar farms out in the middle of nowhere, literally millions of solar panels, thousands of acres. Then you've got the rooftop systems. Then you've got this in between community level kind of, 200 kilowatts to a megawatt maybe. And I think that's going to be interesting to see how they develop, how cities, just how that happens, because oftentimes if they're close to the neighborhood, then that's going to be expensive land. And so that, I'm not sure how that's going to progress. It's going to be interesting.
Thanks, Phil. I have another question, Phil, for you, a little bit more specific, from Robert Nutter of Community Housing Partners, who asks, was the installation of solar PV or thermal on the houses considered? And then additionally, the load bank that was installed with the PV array, was that for volt or VAR control?
Okay. So we did put solar on the Georgia Power Smart Neighborhoods. The developer, to do the neighborhood, we need to work with the builder and developer, and the one we worked with didn't want solar on the neighborhood, I think, for aesthetics. I think that's kind of how that happened. But the neighborhood in Georgia, in Atlanta, does have rooftop solar. And of course, we were able to test out solar on the microgrid with having to do it centralized like that. I think you asked about the load bank. I think that was, so that was, I think, to be able to test the microgrid in islanded mode without putting real customers on it, and then potentially having that fail. So it was just a way to see, okay, are we gonna, can we get the voltage that we need? Is the frequency right? And so you get to hang the load bank off the asset, whatever combination of assets you are trying to employ in the microgrid before you switch it over to the neighborhood. One kind of thing I think is kind of funny, kind of interesting. Kevin may I don't know, he might have some interesting thoughts about this, but one thing that I thought was just sort of funny was that if everything worked perfectly, there was a real outage upstream on the power grid of the Alabama Power Smart Neighborhood, and everything worked, like the microgrid switched over and it picked up the neighborhood. The homeowners didn't know. And I remember thinking, gosh, it would be good if there was a way for them to maybe give them like a little logo or image or something so that they know. But of course, they noticed when it didn't work, and sometimes it didn't work as we were learning how to synchronize it and everything. So it's just I don't know, just I'm probably biased, electrical engineer, power grid industry my whole life. I just think we really undervalue being able to have the lights on all the time, and I just thought it was really interesting that they only noticed when something didn't go wrong. So anyway, that's an observation.
Kevin, maybe you could field that, because it sounds like the Nest or New is really attempting to kind of identify those opportunities and get the customer involved in those decisions.
Yeah, I mean, we've done a decent amount of research. There's a bunch of third-party research out there around this that suggests that there is certainly more room to be having more customer engagement on energy usage and, just kind of system updates. There is probably a ceiling for, customer bandwidth for that kind of stuff. Definitely agree with Phil that we could be doing more. We should be doing more. We think that there is a win in celebrating when the system is working well for customers, and getting them more knowledgeable and engaged about the system generally. So how to do that in a way that is not tedious and is fun and rewarding, delightful, to use the kind of product terminology that everyone in Silicon Valley uses, is tricky. But definitely, part of what our product is built around that idea of being able to have that kind of interaction and engagement with folks, for sure. So noted,
Yeah,
Phil. I'll talk to the
it's
team.
It's this idea. Yeah, it's cool. It's the color your electricity idea is really interesting, because it's, you're moving away from electricity as being a commodity. And I think that along the same lines, I was just thinking, yeah, if your energy is from some resilient source, you probably want to know, especially if you're paying for it in some way through some kind of business model, through a new development or through some other means. It might be interesting. But yeah, we're all energy nerds, so we have to.
Well, that's the thing
ourselves.
Exactly. Like, I don't think I'm revealing anything proprietary if I say that we haven't found that people are excited about staring at their own energy dashboard all day, right? Like, maybe the 45 people on this call, they'd be excited about it, but I don't know that's a broader consumer trend. But we think there is some room there for more engagement, more education, and more celebration of the things going well.
Well, we did get a little bit of a late start, so I'm going to start to wrap us up. We do have up next is a 20-minute virtual networking session. So if I could just kind of pose one last question to everybody, and then apologize that we didn't get to all of the questions, but I do, you do have everyone's contact information here. Our panelists have been, I think, very kind to offer to continue to follow up with folks as needed. But if each of you could kind of talk about one thing that you are excited about the future, or a resource perhaps that you think could really be a steering opportunity for the future for your industry, or smart technology integration in energy efficient buildings, and the connectedness of the community and the utility as well. So the kind of the key takeaway, what are you excited about, or a resource that we really should be keeping our eyes on?
Okay.
I'll go. Okay.
We didn't really talk about it. We didn't really talk about it, but the electrification of transportation, I think, is going to be massive. Working for a utility, it's going to change our relationship with our customers. So I think, and even thinking about just that, we talked a little bit about demand response today. Yeah, Kevin, don't throw the thermostat at me if I say this, but I do wonder. I just wonder sometimes when we're talking about in my little world controlling water heaters and thermostats, I do wonder if the 150 kilowatt hour battery that's in a Tesla or like a Ford Lightning is just gonna be such a much bigger resource. And if those are controllable, does that just dwarf everything else in terms of demand response. So just a question, I might be wrong. People may not want, for other reasons, the utility to touch their battery state of charge in their car, but I think transportation is going to be just a huge game changer for our industry.
Yeah, I mean, I agree with that. Certainly, I think transportation, electrification is a game changer. I guess what I'm excited about, I'll say I think I'm excited about, and I think I'm a little anxious about. I'm excited about the fact that I think we are finally now at the moment when we can seriously talk about a residential distributed energy resource present and future. And I'm excited about the challenge of bringing that online and helping consumers do that effectively. And I think it includes, frankly, integrating their EVs, which is both a huge opportunity and provides an incredible amount of complexity. So, for a company like us, it's super exciting and great to throw our AI and our algos teams and all the smart engineers working at Google into that problem. And to be working with our partners to enable that. The thing I'm worried about, frankly, is I also think this is going to present a ton of really very significant equity challenges. And it's something we got to be talking about, ways to enable this transition in a just and equitable way for everyone. So that is going to be a major challenge for all of us.
Yeah, and that ties into what I was going to say, Kevin, which is that I would focus on sort of the challenge to figure out how to utilize these technologies in a way that does pursue equity initiatives, and in part because, as I kind of alluded to earlier, that's the direction that a lot of the localities that are most inclined to put an effort towards working on innovative, complex project incorporated for the pursuit of greenhouse gas reductions are also now at the same time becoming more focused, and rightfully so, on equity issues and how do we draw the linkage there, and I challenge those of you working at very well deep-pocketed utilities and major tech corporations to look for something like that as your next demonstration project. Is how do we utilize these technologies in I don't know if it's public housing per se, but some sort of affordable housing context in a way that reduces energy burdens for low-income populations.
Great. Well, Kevin, Phil, Damian, thank you all so much for your work to prepare for this and the discussion that we've had here. Thank you to all of our attendees, and thank you, Rebecca, for steering the deck from behind the scenes there. I think Rebecca's going to communicate to us our next steps in our virtual networking up.
Yes, so everybody can go back to the main session, and then we will open some breakout rooms for people to move into if they want to network, or if you want to take this opportunity to go get a snack and have a walk around the block, you can do that too. I do want to point out that our plenary panel tomorrow in person is specifically on diversity, equity, and inclusion. And since that's come up in this conversation repeatedly, I would very much encourage you to try to attend if you're willing to come to the greater Richmond area. But with all of that, we are going to close this breakout room, and the next set of sessions will start at 2:40. We'll have one on workforce development and one on building performance. So thank you guys so much, especially Phil, Kevin, and Damian, and Casey, for all of your hard work and your time.
Cool. Thanks, man.
Can't hear you. Okay. Is this a networking group? Can you guys even hear me?
Yes, we can hear you.
Abby, this is Barry. I'll network with you anytime. You want to go?
Yeah, let's go. Hi, Harry. I don't see you.
Hi, folks. Yeah, we will sort you into some rooms momentarily.
Oh, I like this room. I'm kidding.
Hey, Abby.
This is the main room.
Who just said hey?
Leslie.
Hey,
Hey, how are you?
I'm good. How are you?
I'm good. Are you gonna be at the forum
May.
tomorrow?
Yeah.
Cool. We'll
You
hook
too?
up. You gonna go drink beer?
I'm gonna drive with DC, but sure.
Good. That's my kind of woman.
I'll just continue from last week's conference. I'll tell you that story in our time.
Okay.
Yeah. I'll just say two things. Electric scooters and alcohol don't go well together.
Yeah, I used to live near UVA's campus.
All right, folks. So we're sorry, we're just trying to figure out how we want to do this. We're gonna move Leslie and Abby into a breakout room. If you would like to move into the breakout room with them, raise your hand with your little reaction button down here, and we will move. Okay, sorry. If you would like to move into that breakout room, I see two people have raised your hands. We're gonna move all of you. So we've got Katie Henderson, Kimberly Hunt, Joel Sarmiento, along with Abby and Leslie. We also have two people clapping. I hope that means you.
Maybe they're clapping not to be in our group. No, just kidding.
Thank goodness those ladies are getting out of here now. All right. We will move you. All right, the next person that starts chatting and starts up a conversation, you'll be breakout session number 2.
Is that where we are?
Who would like to go? Who would like to start chatting?
Hi, this is Frank Blanc. I raised my hand, but I'm happy to go in any room. I apologize. I'm outside going inside. It is a windy day.
No problem. No, they're actually still creating that other breakout room. So we're happy to move those folks.
Hey, Scott, are you gonna be there tomorrow?
Scott, Abby wanted to know if you will be there tomorrow. Oh, Abby just went into a breakout room, so. All right.
Good afternoon.
Anyone
Hey, is that Chelsea speaking?
Yes, hey, Matt.
Hey, I just wanted to make sure I was coming in through the right link because I didn't have
Yep.
one in my invite. Okay, good. All right,
No,
just want to
you're
make
good.
sure.
You're good, and I am so happy to see that it's working for you today.
Yep.
Great. Yeah, we have, we'll do the breakout rooms for the sessions in probably about 5 minutes. You are good. I can hear you, so hang tight. Anyone else who's back from a break of any kind? Hi, Kim. How are you?
I'm good. Thank you. How are you, Chelsea?
I'm good. I can hear you. You sound great.
Good.
We also got that on. And I know Carrie is here already.
Great.
So we should be good to go. And Brandy is here already. There she is. Hey, Brandy. Actually, Kim and Brandy, you didn't get a chance to meet. So Kim Brandy is taking over for Jennifer Palestrant, who wasn't able to make it. She's actually up in your neck of the word.
Good to meet you, Brandy. Where are you located?
Right now I'm in Chesterfield County in my home.
Oh, okay. I'm in
Yeah, no, I
Blacksburg.
see Jennifer Palestrant is in your neck of the woods this week. She's up in Kingsburg, Blacksburg.
Oh, cool. Cool.
Folks, if there's anyone who is interested in networking, we do have a networking room going. If you just want to do the raise your hand reaction, not your physical hand, we won't see that. But if you just do the reaction button down the right, we would be happy to move you over to the breakout room to chat. Otherwise, we'll just keep you here.
Sorry, I joined a networking group by accident and then I could not figure out how to get out of it. I was like, oh no, I left where I was supposed to be. How do I get back?
Oh, you're fine. You're back.
Yes, I'm back.
Everyone will be moving into breakout rooms for the panels anyway, but yes, this does just happen to be our panel.
Okay.
All of the people on screen are our panel. So.
Chelsea, can you hear me okay?
I can.
Good.
Yep.
I was going to use headphones, but I think they're a little quirky, so I'm going to keep them off.
No, you all sound great. You all sound great.
Is Jessica or someone going to advance the slides?
I will, yeah. So I'll be staffing the room for you all today.
And then do I ask the questions out of the chat as people ask questions?
We're hoping so. We had an issue with the last panel. Apparently once we put people in breakout rooms, we couldn't make people co-hosts. So we're gonna see if we can make you co-host before we move you. So the answer is hold that thought. But in either case, what I did with Chrissy in the last panel, the questions came to me and then I just copied and pasted them and sent them to her.
Okay.
I have a quick question. So is this also the room for the building performance, the innovations of building performance, or do I have to be sent to a different room for that?
So this is just the main room. It just happens that the whole workforce development panel is here, but we will all get sent to 2 different breakout rooms for the 2 concurrent sessions. So you were in the right spot for now, but we will move.
And I'd like to make sure that I'm saying y'all's names correctly. Brandy Fraser Best Pitch
That's correct.
and
Just like
Matt
baseball.
Hellum. And I have Kimberly Strom, but Kim, should I do Kim?
Either way is fine. Kim is fine.
Okay. And I just plan to do a really brief sentence about each of you at the beginning. And then if you want to add anything about yourself, then when you start your presentation, feel free to.
That's perfect. There is a virtual guide, and all of everyone's full bios are located in the virtual guide. And the same goes for the other panel as well.
Still to be, we're being recorded, Leslie.